Thanks so much for doing that. Oh, God. Let's put it your way. Alright, that's good, that's good. Oh. I don't want you then. That'll do. No, it won't. That won't do. All right, good evening. Apologies that I'm running late and disorganised. We have volume here. Let me try that again. Good evening. Apologies that I'm late and disorganised. I've just rushed out of a meeting that I couldn't leave. All right, so Where are we? This is week 2. You're doing a lab this week on a gentle lab to get us started on regular expressions. There are a few challenge questions that are not so gentle. The story with challenge questions is that they'll range from just a bit harder than a regular lab to impossible. But you don't need to do all the challenge exercises to get full marks. In fact, theoretically, you can get just short of full marks for the lab component without challenge exercises. And most students we're expecting will just do a couple of challenge exercises, maybe. If you're struggling to pass the course, if I said you can have 52 pass and you'd sort of grab it and run out of the door, then you don't need to worry about the challenge exercises at all. If you want 95 HD, you want to be doing every challenge exercise. But don't freak out too much about them. They're meant to add a bit of interest to the course. Next week's lab, shell programming. This lecture, shell programming. And there's a couple of things I have to cover because you need to know them for next week's lab. So let's try and keep things temporally aligned. With shells, it's really nice. If you've just seen C, or even if you've just seen Python, particularly if you've just C is the only programming language you know, but also if you only know a more regular programming language like Python or shells are a lovely thing to expose you to. So we've seen variables. Variables are just strings in shell. So there's a bit of syntax there. You can fiddle with that syntax. That's not important. But I want to show you some more things. There's some weird variables, and you will need to use a couple of these in next week's lab. Variables to get at the arguments, the equivalent of sys.argv for you Python programmers is there. And there's a couple of variables you won't need to use. But special variables. This is the thing that's, yes, it does, and I can understand why it does confuse students. The shell has its own language for sets of strings, which is not as powerful as regular expressions, not nearly as powerful as regular expressions. And you're thinking, why did they do that? Why didn't they just have regular expressions? And I think the answer is the shell designers thought regular expressions were too scary for everyone, so they'd just do a simplified version. I don't know. You can find shells out there that let you use regular expressions, but as I've said, I want to teach you the sort of shell that you can use anywhere, if it's a config file on a Linux box, a server or something like that, or a little embedded system with BusyBox, or configuring something on your general purpose system. So this is what you need to know there. This, by the way, goes by the wonderful name of globbing. I'm not sure I know why it's called globbing. Presumably it's a contraction of global. But globbing is doing this sort of matching. If a string in the shell contains those characters, there are actually a couple more that get supported by a lot of shells, but they're the really interesting ones. Asterisk, question mark, and square brackets. It's used to generate a set of strings, but by reference to file names. So if you say and, the meanings are different for the first two to regular expressions. Square brackets is more or less the same, sort of the same. Well, it's roughly the same. You can't invert with a caret in shell, I think. So, we've seen that, but let me just show you again. So if you want to match all the files that have a one-character suffix, you do it like that. Note, the dot there has a special meaning in regular expressions, which you'll get very used to. Doesn't in shell. So there, the asterisk matches one or more characters in a file name, and the question mark matches a single character. And if I want to say C files, I could say, tell me about all the files ending in .c or .h. No .h files there, but you get the idea. Globbing, shell scripting. Oh, we'll talk about that. Yeah, I talked capturing the output of a command. And we finished the last lecture showing you back quotes, which were really weird, where they say, run this program and capture its output. I guess not so weird if you've explored Python, because you can do that it's pretty easily with sub-process in Python. It's not so easy to do the same thing in C, though. Quoting, we've talked about back quotes. IO redirection came up in an earlier lecture. There it is at more length. Another horrendous piece of syntax, as far as I'm concerned, is the one to say, make this stream go to the same place as the other stream, which you will see people doing when they want to say, send standard output to the same, say, standard errors going, or vice versa, which is that 2 greater than %1. Don't worry about that. That's definitely not something we'd require you to know in the exam. But you will see that. I've seen all of this before. Oh, yeah. Let's try a bit of programming. See if I can come up with some examples for some of these things. Yeah, I think that's probably best. All right, a shell if statement. Those, well, that's not all the keywords. There's else and there's elif, if I've got that right. Those are all the keywords for a shell if statement. They're thinking, what? 5 different keywords for an if statement. What were they thinking? Well, it's pretty apparent that was popular in languages preceding shell. To have to be keyword rich, I guess you'd say. And Python, sort of the ultimate reaction to this, to give up on the keywords almost entirely, and use the white space to denote the body of statements. So it's interesting to see. Let's give you an example of this. Actually, there we go. Let's change this a bit. If there we go. So the then part and the else part will be a sequence of programs to run. So shell scripts, when you program in shell, you're basically listing programs to run. So every line is a program to run. One of the nice things I like about teaching students C and C programming, it gives you a pretty good feeling for the computation on a modern machine, because there's roughly, more or less, a one-to-one correspondence in every symbol in a C program and an instruction on a modern machine. As machines have got more cores, more parallel, that's held less, but you still get a good feeling for the nature of the computation on a silicon CPU, a modern silicon CPU, when you're writing C, because there's this fairly close mapping between operations there. You put down a plus in a C program, 1 instruction. Put down an assignment, 1 instruction. Doesn't hold in shell, nothing like it. You put 1 single line in a shell program, you can be talking 10,000, you could be talking 100 instructions if you're really lucky, but you're probably talking 10,000 to 1,000,000 instructions executed. So suddenly the world has changed dramatically. So everything is running a program. Oh, wait. the condition on an if statement. So you're expecting it'll be a Boolean valued expression. Oh wait, I'm coming from C. I'm happy with it being an integer value expression, 0, false, everything else true. No. In shell, you put what you put there is a program to run. So you say run this program. You're saying what, Andrew? You can say if, rm file, or if date, or if GCC. Yep. But what does that mean? How does that translate to true or false? Every Unix process, when it terminates, supplies back to the operating system a number. A number. Oh, I should have researched this beforehand. I've forgotten what it is. Is it 16 bits on a modern system? I'm not sure. It used to be, long ago, it used to be 8 bits. And to tell the truth, it's effectively 1 bit. Well, maybe a couple. Most programs just return 0 or 1. Some programs return 0, 1, 2, or 3, and there are circumstances that use a few more bits. So they just return a few values. The convention, let me emphasize that word, the convention, nothing forces programs to do this. It just relies on the goodwill of programmers writing programs. The convention is that if your program is executed without problems, without errors, done what it's supposed to do, it exits with status 0. And you'll have seen that hopefully when you've learned C programming. You've said return 0 in main, and that's passed back to the operating system. Alternatively, you can call exit, in Python sys.exit, with a number, same thing. That says I'm stopping, I'm passed back to the operating system this little number to say how things went for me.
What if the C function, main function is void? So it doesn't return it.
Void main. Is void main a legal C program? Oh. There are actually 2 legal prototypes for main in a C program. One is int main void, and one is int main int argc. You don't have to call it argc. Char star argv square brackets. You can change that a little, but those are effectively the 2 legal prototypes. Both return an int. If you stuff up your main, the support code that the compiler supplies will pass back a number to the operating system. You can research this about what happens in weird circumstances about when your program's terminated. I think a number gets effectively supplied, but a number goes back for every program to the operating system, one way or another. And you're saying, could I go home tonight, Andrew, and write a program and try return 5 and things like this, and try not return things, try and declare main as void? Yes, you could. I encourage you to do that. What could be better to do after uni? Go home and write some C programs. I know I will be. Actually, I won't, but I wish I could. All right, so LS. So I'm boring you here. I'm sorry. There's someone yawning. Well, no, maybe he's yawning because he spent all last night programming. We can hope. So how do we know what this number is? I run ls Fred. I think it might be returning a non-zero code because it couldn't access that file. There's a special variable called $, which is the exit status of the last command run, and hopefully that will show a non-zero number. 2. What does that mean? Who knows? Yeah, you could probably look it up in man ls. So let's say ls a file that exists. I don't know why there's a file called that, but that file exists, and we'll look at what it ls exited with status 0. So it's a bit frustrating if you teach first year C, first session, first year C, because you're always saying, yeah, you have to return the status, but students never ever see the point of it all, and there isn't any value to the status you return until you start putting your C programs inside a script where they are, for example, used in an if statement. So until you write a C program that gets used in an if statement or the other context like that, it doesn't matter. All right, so I've got a program here that, I can't remember what I called it. Program, yes. No imagination there, Andrew. Missing operand. Chmod it. Make it executable. That's the octal description of the bits. You can look that up. Wait a minute, I'll show you it worked. I guess is that worth explaining? I guess it's worth explaining. That's 755 there. If you look at these bits, if you take the read, write, and execute bits going across as each is an octal number, and the R is the 4-bit, the W is the 2-bit, the X is the 1-bit, you can describe all the bits as a 3-digit octal number. Why would you do that? I've just been doing that forever. So I think when I started using Chmod, there wasn't an alternative. The symbolic version might be better, I guess. It's sort of useful. I don't mind actually showing it to students because it gets you thinking about the bits. Not as much as you'll have to do if you do operating systems. Sorry, when you do operating systems. How could you come here and not do operating systems? When you do operating systems, and perhaps advanced operating systems. Let's run the program. It's a bit annoying, and this is the thing you'll see many times. I'm suddenly at this stage, I'm running ls, but I actually don't want the output for ls. All I want is its exit status. So, and you get to this circumstance, you see it saying ls, I don't care about that error message, I just care about ls exiting 2 to say the file doesn't exist. So what do? There's three options. I could get the source to ls, change it, to not do that. Not a bad thing to do tonight, but I can't do that here now. I could read man ls and see if man ls has got an option to say, don't give me any output. Sometimes programs do that, just for this reason. The third option, what's the third option that'll work always? It's to redirect the output. So I could say, I could do this. What's wrong with doing that? There's a couple of things wrong with doing that. One is, maybe I have a file called junk file and I'll be overwriting it. That would be bad, bad, bad. So we don't want that. Anything else that might not be good there? Don't tell them. You're the sort of person, and we had in Comp 511 last session, we had a tournament, and students they could give their bots names, and there were students who were putting spoilers for Infinity Wars as their bots' names. And you're that sort of person, aren't you? No, I haven't seen it, so no spoilers for Infinity Wars. All right. The other issue that might happen, by the way, is I can't write to the current directory. So don't create files in the current directory if you're writing a utilities shell script, unless you really have to, because you might be running somewhere you're not allowed to create files. All right. Having abused you for spoiling Infinity Wars for me unfairly, what did you want me to do? Didn't you say dev null, or was that someone else? Dev null, my favorite file. All right, it's actually a device. We'll actually list it and show it to you. I don't know if Kevin gets you to write device drivers, but it has some of the easiest device drivers you'll ever write. So a device driver for a device has to say what you do if you send bytes to it, what if you get bytes to it and from it and something. And it has a particularly simple implementation. You can send as many bytes as you like to dev null and they're just thrown away, they're ignored. It does nothing with bytes written to it. And you can try and read as much as you like from dev null and it gives you nothing. It's great. All right, so why do you have it? When you want to send a stream of bytes that you don't need, you just need to send them somewhere. So you send them to dev null, and the operating system throws them away. All right. So this should just give me the message saying, actually we'll change the message. There we go. So it just should say, I run it, and it should just say, oh my God, dev null's broken. Right. This is your fault. Yeah, oh yes, yes it is. You had me send output to dev null. You said this was a solution, but it's not. You're blaming LS. Oh, I think it's your fault. All right, help him out here. Someone else, help him out. Every Unix program has how many output streams? 2. Standard out and standard error. Which one did you want to redirect? So you got me to redirect standard output. Well, actually, I did it without you really asking. But I wanted to redirect standard error. All right, and the wonderful syntax for this is, yes. All right, so the syntax is, the negative is there's all this horrible syntax that you have to get across. The 2 positives is we've only let people into this class who are incredibly smart, and if you can master all this sort of stuff, get good at assimilating syntax well, quickly, you'll learn programming languages, you'll learn systems, you'll get so much better at doing these things, you'll be able to do exciting, important things, be paid money, that sort of thing. All right. I've got rid of the annoying error message, sent it off to dev null, and now I've got a program. Let me create important file.txt. All right, let's keep. Oh! Again, you've let me down. What's happened now? It's putting stuff on standard output. All right, so this is a good example, actually. Considering how disorganized I am, this is working quite well. I wanted to do this, which is a bit cumbersome, and then that says, I don't want standard out from this program either, but there's another trick which you'll often see, and it has some advantages in other situations where you want the output to overlap. Does that have advantages? Anyway. Is you often write it like this. That says standard output to dev null and send standard error to the same place. Am I telling you the truth? All right, so now I've got a program I can run that tests whether important file.txt exists or not. So you're working on your major assignment for another course. You can have a script set up. You can run this test script. Okay, you'd have to be pretty paranoid. You're thinking, Andrew, but I just don't want to check once. I want to do it in a loop. I want to do it repeatedly. I want something watching. And we can do that. And you're saying, Andrew, can I have more keywords? Yes, you can. The shell loop is while do done. And there we go. So that will run ls, and if ls exit status 0, it'll go around the loop again. Otherwise, the loop will terminate, and it'll tell me important file.txt does not exist. So let's try this out. Nothing could go wrong with this. Nothing ever. Let's try it out. Oh, did I write the file? Oh, the file doesn't exist. So it works. Look, the file doesn't exist. It stops. Tells me the file doesn't exist. I'll create the important file. Create it. Run the program. Everything. All right, there's a lot of messages here. That's actually not a great thing to be doing. All right, if it's your own laptop, I don't care, but do this on servers, and you might find our system staff getting grumpy with you. I'd call that busy waiting. I'm going, does this file exist? Does this file exist? Does this file exist? As fast as it can. That's probably a bit overkill. So let's say I'm super paranoid and I only want to check every minute. I'd say here, sleep 60. You're saying, Andrew, the sleep command, isn't it going to just sit there? Is 60 seconds up? Is 60 seconds up? Is 60 seconds up? No, actually, it does it quite efficiently. It says to the operating system, just wake me in 60 seconds. And then no other work is done. Again, you really want to do operating systems, don't you, to understand why that's easy for the operating system. When you do a loop in a shell program, always add something like that. Don't sit there bashing away if you're monitoring something. Sleep for 1 second, 10 seconds, an hour, whatever's appropriate. So I'll change this to sleep for, say, 3 seconds. Oh. And I'll add something to put the date there. Look at that. Using back quotes to get the output from date and add it to the line that echoes printing. Am I a good shell programmer or what? 1, 2, 3. 1, 2, 3. So now we have a daemon that's monitoring important file.txt every 3 seconds. All right, so this is a really stupid example, but it's not hard to think of 5, 10, 15 important things you could do like this. And let me remove important file.txt, and in 1, 2, come on, it stops. All right. So nice example. Questions about that, because I've got to keep moving. There's a couple more constructs I want to get through for your programming pleasure in next week's lab. Well, it's only the people who have Monday and Tuesday tute labs, so we could just say stuff them and go slowly. That would be bad, I guess. All right, I won't do that. Let's keep moving. I'm nice to the people with Monday tute. We try to pick nice tutors because it's not good having a Monday tute lab. Everything's always new and fresh and has bugs. One more loop construct. Let's show you one more loop construct. Actually, no, let's show you arithmetic. Arithmetic. Combined with a loop. It's a good chance to bring in another command, the test command. What does the test command do? It's another one of these things you never use on the command line. It doesn't produce any output. No, never writes to standard output. Can produce error messages in some circumstances. No standard output. It exists only to have an exit status. You can use it in various circumstances. One thing you can do is say, does this variable interpret as a number less than another variable? So we can count up to 42. Oh, no, that's not what I wanted. Expra, sorry. You remember the Expra program's this weird program that exists to do arithmetic? So this should count up to 42. So I've got this right. What? It's obvious what I mean. What's wrong with line 4? I've said we only let smart people in this class, which is fortunate because you can fix my problems for me. What's my problem on line 4? The less than symbol, yep, all right. He says the less than symbol. Keep going.
It's interpreting as direct 42 file into that.
So it's the shell's interpreting the less than as IO redirection, and there's no file 42. Oh, interesting. All right. And in fact, that was a brain fade for me. The test command, you're saying, are you serious, Andrew? Yes, sadly I am. If you want to do an arithmetic comparison, you have to say dash LT. Whoa. All right. That's not good, is it? That's not pretty. That's not pleasant, but that should work. All right, so that is classical shell arithmetic using two other programs that exist only to be run from shell scripts. Test and Explorer. And it is possible you'll meet platforms where these are your only recourse. So it is possible. If you're trying to write a shell script that runs absolutely anywhere and everywhere, you'd probably use those programs. Now, if you're trying, it is ugly, it's not pleasant. So shells got extended, particularly I think they started with bash, to provide these features in a perhaps more pleasant way. And they're pretty widely supported. So let me show you an alternative way to write this. Most shells have arithmetic built in with this bash syntax. Most people call it bash arithmetic. So I can say now, I can put two brackets and say that. If I've got that right, that should work. There's a couple of syntaxes I can use here, but one I like is $brackets, and that. So essentially saying between the double brackets you can put arithmetic expressions. Even better, you don't even have to put the dollars on the variables. And that is more readable. You're saying, Andrew, your remote control on your TV at home runs a shell. Will it support that? Yeah, I'm not 100% sure. So you want to be careful if you're in embedded situations, for example. Have I told you the truth? Oh, look, I have. So that's the alternative arithmetic syntax, doing the arithmetic in the shell. But it's very important that you see the old style. It's needed sometimes. Not so much Explorer. Test has a number of flavors. Oh, well, that was all good. Let me say again, the shell is Turing complete. Any program you want to write can be done this way. But say you're interning, you get a summer job in the elect department and they want you to do some complex analysis. Please don't start trying to multiply matrices in shell. No. So once there's more than a little arithmetic, you should be thinking maybe another language. Python, Perl. There's other choices as well, but they're probably not in the right language if it's arithmetic heavy. Lots of things just need a little arithmetic, though. All right, let me show you one more loop and then a few more constructs that might be useful next week. Try to be a good lecturer. Is that how you spell Hermione? I'm never sure. you don't actually see loops like this, but there's a loop that runs once for every word. Yeah. So it's another piece of syntax. You get do and done, just like a while loop, but you get for and in. You've got more keywords in the last few minutes than you can get in the whole course from other languages. But let me say again, don't panic. In the exam, you've got a cheat sheet that gives you the structure of these loops. You won't be sitting there. Is it do? Is it odd? Is it, yeah. You get reminded of the syntax. And you do a bit of programming, you don't forget it anyway. Doesn't seem, it's not, yeah, you don't often explicitly give the words. Occasionally you might do that. I guess something you might see more often is something like this. So you want to run a particular command on a particular machine, you might do something like that. So for this list of machines, go there and do this command, something like that. That's a common use of that sort of construct. Much more likely is to see something like this. To get your list of words that your for loop's going to execute for with a shell glob. So for all the C files in the current directory, run GCC. You're saying, Andrew, but that'll put them all in a.out. Ah, but I'm on that. I am so on that. You want to compile Hermione.c into Hermione. I know how to do that. Echo $file and use the sed command which we mentioned to get rid of the .c on the end. Look at this. I know regular expressions. Anchor the match to the end of the regular expression, and that will get rid of the .c at the end. So if Hermione.c exists, that will compile. I'm actually going to try running that. That might even work. We've got some .c files. Does that work? We can only be brave. Oh, why? Why? All right, let me show you another useful trick here. So our shell programs run off and run some programs. You're saying, Andrew, add printfs. There is actually a program called printf that acts like the C function printf. It's quite useful. You can use it, but for debugging, you'd normally just get by with echo. But if you need formatted output in a shell program, you're thinking, oh, I wish I had printf and %3d or %.1.6f. There's a program called printf that does that sort of thing. Widely available. But it can add an echo, but what you often do is this. That says, turn on the shell's -x option. Pretend the -x option was set on the command line. She's saying, what's the -x option? It says, tell me every program you execute. So it's handy for debugging. So we can see what's going wrong maybe with this. Oh, I'm running, what have I done? You should have put file. All right. File or $file? All right. Let me repeat. You know, you've always wanted that job at Snapchat. You're sitting there in the interview. You don't want to be saying file. No, I mean $file. Precise, clear. You know, you're on top of things, but you want to be. You've got to get better at that sort of thing if you want that job of a life working at Snapchat. I don't even know where Snapchat is. Are they San Francisco? I don't know. Maybe they have a Sydney office. It's not working. Oh, come on. File, dollar file, remove the .c. You're not helping me out here. All right, so we're saying for file in... I'm being mean. All right, I'll give you a Mars bar. You're trying, which is more than the rest of you. Have I got a Mars bar? Oh, maybe I don't have a Mars bar. Oh, no, I do. Mars bar? You want a Mars bar? So who was it you suggesting the file and dollar file? Who was that? That was you. There you go. There's the Mars bar. All right, you suggested the IO redirection, which sort of worked, so you can have a Mars bar as well. Okay. Well, actually, as I said, they're all the equivalent. They're almost as good. I kind of really like them, but anyway, that should work. Oh, look, it is working now. That's set minus x showing the commands executed. So it's gone through all the C, so it's compiled unique.c and put it in a file called unique. Compiled grep.c, put it in a file called grep, and so on. Why is that a bad idea, by the way? What I've just done. If I say unique or WC, it's running my own version. Is that good? Maybe not. Maybe not. But I'm on top of that. I'll comment that out. And remove this. Oh. You're thinking, oh, that's a bit scary. Is that going to remove the right files? I could be brave and run it. So real programmers are brave and run it, but have excellent backups. But what you might also do is print out, say echo, I think I'll run that RM and see what that prints. It's going to do the right thing. Now remove the echo, run the program. It's removed those files. So if I run cat or count or grep or unique, I'm sure I'll get the system one. Would I have got those ones? Depends where the dot's in my path and where it is in my path. And you can think about that. All right, now there's something at least I have to show you. You've seen ifs, you've seen tests used with a less than, that's all in this. Oh, ampersand and or. What if I want to yes, and an or. Oh, let me show you something. It's quite nice. Test will let me test if a file exists. Test minus R will return true, an exit status of 0. Wait, why is that confusing? What's 0 in Python and C as a Boolean value? False. What's an exit status of 0? It's sort of true here, isn't it? Your brains may explode before the end of session, as I've said. It's a good thing you're all so smart and attractive. Did I mention that? Two ampersands is run this command, and if it exits with status 0, run the next command. That gives you Boolean AND. Two vertical bars gives you Boolean OR. That says run this command, and if it exits with a non-zero status, run the other command. So it lets you chain commands together. And if Andrew writes the file, we'd actually see that in operation. Neither file exists. So I could do this.